How can voltage, current, and power be used to predict the behavior of electric circuits? This is the question students explore in Investigation 17F, Compound Circuits. The brightness of a bulb is directly related to its power, which you will remember is a measure of how much energy passes through the bulb in a certain time. In Part 1 of this investigation, students will predict the brightness of bulbs in circuits, create the circuits, and then check their predictions. They will take measurements of voltage and current, calculate the power, and use these values to explain their results. In Part 2, students will construct a voltage divider circuit using two different resistors. They will measure the input and the output voltages and observe how they change when we change the resistors in the circuit. For Part 1, students begin by predicting the brightness of bulbs in a circuit that includes series and parallel branches, as well as a switch. After they have made their predictions, students will create the circuit using 3 light bulbs, a switch, and 2 batteries. Look at the brightness of bulbs 1, 2, and 3 with the switch open, and then close the switch and see how each of the bulb's brightness changes. You may have to get close to a bulb and shield it from outside light to see that it is still lit. Bulb 1 is brighter with the switch closed because the equivalent resistance of the entire circuit is less, so the current through bulb 1 is greater. Since the power depends on the square of the current times the bulb's resistance, bulb 1 will be brighter with the switch closed. Let's add voltage and current sensors to our circuit to confirm our explanation. We will start with the current sensor in series with bulb 1 and the voltage sensor in parallel with bulb 1. Each group will open the experiment file, 17F, Compound Circuits, in SparkView, and then connect their current and voltage sensors using Bluetooth. We click to start recording data and record our voltage and the current with the switch open, and then we close the switch and record our current and voltage again. The power can be calculated from the voltage and current using power is equal to the current times the voltage. From our numbers, we can confirm that the power is greater through bulb 1 with the switch closed. What about for bulb 2? We observed that it got dimmer when the switch was closed. Since current through bulb 1 increases with the switch closed, the voltage drop also increases since it depends on the current and the resistance. If the voltage drop across bulb 1 is greater with the switch closed, the voltage drop across bulbs 2 and 3 must be less because we have the same battery source, and the sum of the voltage drops must equal the voltage from the batteries. Power depends on the square of the voltage divided by the resistance, so bulb 2 will be dimmer. Let's check our results using SparkView. This time we will connect the current sensor in series with bulb 2 and the voltage sensor in parallel. Again, we click to start recording data, recording our voltage and current with the switch open, and then we close the switch and record voltage and current again. The power can be calculated from the voltage and current. From our data, we can confirm that with the switch closed, the power is less through bulb 2. For Part 2, students will use the 10, 33, and 100 ohm resistor modules to construct voltage divider circuits using 2 resistors at a time. We will connect the 2 batteries in series with the 100 ohm and 10 ohm resistors. We'll use the SparkView experiment file that we used in the previous section. We'll measure the input voltage across the batteries and record that on our paper, and then we'll measure the output voltage across resistor R2. We don't need to use the current sensor, so we can ignore its numbers. Replace the 100 ohm resistor with the 33 ohm resistor and repeat the measurement. You can make a measurement of two 10 ohm resistors by sharing with another group. The voltage drop is proportional to the relative size of the resistor. The voltage has been divided between the resistors. A voltage divider circuit may be used to measure the resistance of elements with varying resistance, or to adjust the amount of voltage passing through elements connected in series in a circuit.